Hello. Today we're going to learn database management in software development. In Module 5 we have these topics: relational database concepts, SQL and NoSQL database modeling and normalization. Relational database concepts refer to the fundamental principles and structures that underpin relational databases. A relational database is a type of database that organizes data into one or more tables, with each table consisting of rows and columns. The tables in a relational database are related to each other through common fields, allowing users to query and retrieve data across multiple tables. Here are some of the key concepts related to relational databases. 1. Tables. In a relational database, data is organized into tables. Each table consists of rows, also called records, or tuples, and columns, also called fields. Each row in a table represents a single instance of the data being stored, while each column represents a specific attribute or piece of information about that data. 2. Keys. Keys are used to uniquely identify rows in a table. A primary key is a column or combination of columns that uniquely identifies each row in a table. A foreign key is a column in one table that refers to the primary key of another table, establishing a relationship between the two tables. 3. Relationships. Relationships are used to link tables in a relational database. A one-to-one relationship exists when each record in a table is related to exactly one record in another table. A one-to-many relationship exists when each record in one table is related to many records in another table. 4. Normalization. Normalization is the process of organizing data in a database to reduce redundancy and improve data integrity. The goal of normalization is to ensure that each piece of data is stored in only one place, to prevent inconsistencies or errors that can occur when data is duplicated across multiple tables. 5. SQL. SQL structured query language is a programming language used to manage and manipulate data in a relational database. SQL allows users to create, modify, and delete tables and records, as well as perform queries to retrieve and analyze data. SQL and NoSQL databases are two types of database systems that are commonly used in modern software development. SQL databases, also known as relational databases, are based on the relational model of data, which organizes data into tables with columns and rows. SQL is used to query, update, and manage the data stored in these tables. SQL databases are known for their strong consistency, transactional integrity, and CID atomicity. Consistency, isolation, durability, compliance. They are typically used in applications where data consistency and reliability are critical, such as financial systems, inventory management systems, and healthcare applications. On the other hand, NoSQL databases are designed to handle unstructured or semi-structured data, such as documents, key value pairs, and graphs. They are often used in applications where data volume and scalability are important, such as social media, big data analytics, and IoT Internet of Things applications. NoSQL databases are typically more flexible and can scale horizontally by adding more nodes to a cluster rather than vertically by adding more processing power to a single server. However, they may sacrifice some consistency and transactional integrity for increased scalability. Performance. There are several types of NoSQL databases, including :1. Document databases. These databases store semi-structured data as documents, such as JSON or XML files. Examples include Mongo and Couchbase. 2. Maps to a value. Examples include Redis and Riak. 3. Column family stores. These databases store data as columns rather than rows, allowing for efficient querying of large data sets. Examples include Cassandra and HBASAC. 4. Graph databases. These databases store data as nodes and edges, allowing for efficient querying of complex relationships between data entities. Examples include Neo4j and Orient. The choice between SQL and a NoSQL databases depends on the specific requirements of the application, including data structure, scalability, performance, and consistency. Data modeling and normalization are two important concepts in database design that help to ensure data consistency, reduce redundancy, and improve data integrity. Data modeling is the process of defining the structure of a database, including the tables, columns, and relationships between tables. The goal of data modeling is to create a logical representation of the data that can be easily understood by users and developers and that can support the requirements of the application. Normalization is the process of organizing data in a database to reduce redundancy and improve data integrity. The goal of normalization is to ensure that each piece of data is stored in only one place, to prevent inconsistencies or errors that can occur when data is duplicated across multiple tables. There are several levels of normalization, known as normal forms, with each level addressing a specific type of data redundancy. The most commonly used normal forms are 1. First normal form 1NF. This requires that each table in a database has a primary key, and that each column in the table contains atomic values, i.e., values that cannot be further broken down closing parenthesis ... Second normal form 2NF. This requires that all non-key attributes in a table are fully dependent on the primary key. In other words, each non-key attribute must be related to the primary key, and not to other non-key attributes. 3. Third normal form 3NF. This requires that all non-key attributes in a table are independent of each other. In other words, each non-key attribute must be related only to the primary key, and not to other non-key attributes. Normalization is important because it helps to ensure data consistency and integrity, reduces the risk of data anomalies, and makes it easier to maintain and update the database. However, over-normalization can also have negative impacts on performance and usability. So it is important to strike a balance between normalization and usability when designing a database. Thank you for watching US.